Guys, Mr. Bowman here. Today's learning objective is in white, and we are learning to apply the basic indice rules. And specifically, we're going to focus on the rules relating to multiplying, division, and brackets, and how they relate when you've got powers involved. So, first rule we're going to look at is multiplying powers, and just a fairly basic example to get us into. So if you're at x squared times x5, what we do here without really knowing it is we just kind of add together the powers. So that's x2 plus 5, and that combines to get x to the power of 7. So the rules that we're looking here, or the rule that you guys should be looking to remember, if you got x to the power of a and you multiply that x to the power of b, your answer x will be a plus b. So you're really just adding the powers together. So let's do a couple of examples to get into that, and then we'll have a look at division afterwards. So maybe example number 1. So let's say you've got x6 times x7. Same rule, add together the powers, and that gets us x to the power of 17. So that's the most basic of scenarios. We can make that more complicated by having letters or numbers in front of it. So let's say we've got 3y2 times 4y3. Don't forget we multiply the numbers up front, which is 12, and then we add the powers together, 3 plus 2, and that's going to get us to 12y to the power of 5. So hopefully that's fairly basic. So let's look at one more complicated scenario which may come up from time to time. So let's say we've got -4, so we'll put in some negative numbers, x -2 times -5 x -3. So I just want to know, we've got some negative numbers here, and the same rules still apply, so we're still adding them together. So we've got -4 and -5 to start off with. That's going to be positive 20. And then we're going to have x -2 plus -3, and that would come to -5. So x to the power of -5. We will look and explore specifically negative powers and how that works in a bit more detail later on. But at the moment, we'll just leave that there. And that should be example 3. And the third example I want us to look at here relates to having a lot of variables and a lot of unknowns. So even though you've got letters that you're doing algebra, these rules still apply. So let's say we've got ax to the power of 2b plus 1, and we're multiplying that by c, maybe 2 minus 3b. Oh, apologies, I just put an x there because that should be to the power of. Same rules apply. You'll do letter times letter up front, so that's a to the power of c. And then when you have a look at the x's, you're just going to add together the powers. So we're going to be going x, so that's a multiplication still. So we've got 2b plus 1, and then we're going to add 2 minus 3b. We then simplify what we can. So we've got acx, and we've got 2b minus b is negative b, and then these add up to 3, so we've got 3 minus b. So hopefully you can see, even though if you've got a whole bunch of letters or algebraic variables kind of muddled around inside your indices, the same exact rules are going to work regardless. All right, let's now have a look at dividing. And the basic example we want to have a look at, so let's say we've got x to the power of 6. That's being divided by x squared. The way we normally go about that is we go, well, 6 minus 2 is 4, so that's going to get us x to the power of 4. And if you think of that in terms of letters or as a rule, we've got x to the power of a divided by x to the power of b. That there is simply just going to be a minus b. So it doesn't matter what a or b is. It could be a negative number, it could be a positive number, it could be another variable. We've still got to go through that same process. So let's have a look at some examples in relation to division. So the first one I want to have a look at, so let's have a look at x to the power of 8 divided by x to the power of 5. Same thing as we just did, simple. We're going to go top power minus bottom power which is going to get us x to the power of 3. So hopefully nothing controversial about that. You may also have some numbers up front of the x. So let's say you had a look at 10x to the power of 10 divided by 5x to the power of 5. You would do the same process like multiplication. 10 divided by 5 is going to get you to 2. You then have a look at the powers. You go x, 10 minus 5, top power minus bottom power, and that's going to be 2x to the power of 5. The same rules work with negative numbers and positive numbers as well. So I mentioned that before, so we need to know how that works. So let's say you've got x cubed divided by x5. That is going to become x top power minus bottom power. So don't get those the wrong way around, because your answer will be very different, and that's going to be x negative 2. And again, we've got a negative power here. We're going to look at negative powers in a bit more detail by themselves later on. And the final example, let's have a look if there's some other kind of letters going on. So let's say we've got 30x to the power of y divided by negative 6x to the power of 2a. Same thing's going to apply here. Let's have a look at the numbers up front. That's going to become negative 5. We're then going to go x top power minus bottom power. And then just for fun, I'm randomly going to throw in a final question. So let's say we've got negative 20b to the power of c minus 1 divided by negative 4 to the power of b of 2c minus 3. The same process is going to apply. Numbers up front, negative 20 divided by negative 4 is positive 5. And then we've got b, and we're going to do top power minus. And just noting here, because the denominator is got multiple bits to its power, I've just put that in a bracket to make sure, and I'll show us why that's really important. So 5b, we've got c minus 1, and then we're going to expand that bracket to get minus 2c plus 3. And that plus 3 is why I put it in brackets. A lot of people are going to write down negative 3 by mistake, forgetting that it's a negative minus a negative. And when we simplify that, we're going to have 5b, and then we're going to have 2 minus c. So that is division. What I'm going to do is I'm going to pause the screen down, and we're going to have a look at some brackets and questions as well. All of those are cleared, and the last set of rules that we want to have a look at today, I'm going to write them down the bottom here, is we want to look at the bracket type questions. And there's a few different scenarios that we need to be aware of, but the generic rule I want us to remember, so if we got x to the power of a, and all of that is x to the power of b, we're going to multiply those powers together. That's x to the power of a times b. And there's a slight variation of that if you've got a fraction. So let's say you've got x to the power of a divided by y to the power of b, and you multiply that to the power of c. Just a reminder that the top part is going to be to the power of c, and the bottom part is going to be the power of c. And then we'll then use the earlier rule to simplify. So that's a times c in the end, and then that's b times c. So we'll look at a few examples like that in a bit more detail, but some of these are going to get a bit messy, particularly those ones with powers down the bottom. So let's have a look at our first example. So example number 1. So we'll start off with a nice easy one. So let's say you got x to the power of 10, and we're going to cube all of that. We're going to go x 10 times 3. So we're going to multiply the two powers together, and that there will finish us up with x to the power of 30. Now we'll extend it a little bit. Let's add a number in front of the x to see what happens with that part there. So we've got example 2. So let's say we've got 2x squared, and we're going to put that to the power of 4. Now this 4 applies to both parts. It's going to apply to the 2, and it's going to apply to the x squared. So it's going to be 2 to the power of 4 times x to the power of 2 times 4. 2 to the power of 4 is going to be 2 times 2 is 4, times 2 again is 8, times 2 again a fourth time is 16, x to the power of 8. So don't forget, it applies to each component separately. A few of us are going to write down 2x to the power of 8. But that is 100% wrong. That 4 applies to the 2 as well. The same works if you've got letters in your powers as well. So let's say we've got y to the power of a plus b, and that there is cubed. That there is going to be y, and we're going to go 3 times a plus b. If you do want, you can expand that. You can have y to the power of 3a plus 3b, but both of those answers would be considered correct as well. So we've done a little bit in relation to powers. Let's take it up a step. Let's get into the brackets. So we've got example 4. So let's say we've got x squared divided by y cubed, and that there is going to be squared. So the first thing is to split it off. So that top portion is going to be split. So x squared is then going to be squared, and the same happens to the bottom portion. So we've got the 2 brackets. We're going to apply that single bracket rule twice. So we're going to multiply the powers together. So the first one is going to be x to the power of 2 times 2, and then that's going to be divided by y to the power of 3 times 2. And when you simplify that, that's x to the power of 4 divided by y to the power of 6. And we're going to finish up with one more example, probably the hardest one we're going to look at as well. So let's put a number out front each of them. So let's say we've got 3a squared, apologies about that, divided by 4a, oh no, let's get rid of the a, 4b squared c cubed. And let's say we're going to square that as well. So just a reminder, the top and bottom parts all are subject to that square. So that's going to be 3a squared, which is then going to be squared. That's going to be divided by 4b squared c cubed squared. And then just the note, that 2 applies to every part within the brackets. That's going to be 3 squared times a squared all squared. And the same down the bottom, 4 squared times b squared, which is squared, times c cubed, which is squared. And we can then simplify that. 9, so 3 squared is 9, a to the power, a squared is that, so 2 times 2 gets us to 4, so that's going to be a to the power 4. We've then got 4 squared is 16, b squared times 2 is b4, and then we've got c to the power of 6. So the bracket ones can get a bit complicated and a bit more of a nightmare. Just a reminder, the same things apply. Even if you've got negative numbers, even if you've got other variables, the exact same rules are going to apply as well. So don't be afraid of questions like that. So guys, we did 15 questions, I think 14 questions that helped us apply multiplying, dividing, and bracket indice rules. Hopefully you found them useful. If you haven't got the notes and the examples down, make sure you do. Now let's get into heaps and heaps of practice.